Hello friends, today we are going to discuss about boiler. Let's quickly see what we are going to discuss today. Firstly, we will go through introduction to boiler and boiler specification. Then we will discuss about boiler regulations. Then we will discuss how boilers works. Next we will discuss about boiler types and classifications. Then we will see how to evaluate performance of boilers. Further we see blowdown requirement and boiler. Then discuss about recommended boiler and feed water quality. And finally, most important topic, energy conservation opportunities. So let's start our discussion with introduction to boiler. A boiler is an enclosed vessel that provides a means for combustion heat to be transferred into water until it becomes heated water or steam. The hot water or steam under pressure is then usable for transferring the heat to a process. Water is a useful and cheap medium for transferring heat to a process. When water is boiled into steam, its volume increases about 1,600 times, producing a force that is almost as explosive as gunpowder. This causes the boiler to be extremely dangerous equipment that must be treated with utmost care. The process of heating a liquid until it reaches its gaseous state is called evaporation. Heat is transferred from one body to another by means of 1. Radiation, which is the transfer of heat from a hot body to a cold body without a conveying medium. 2. Convection, the transfer of heat by a conveying medium, such as air or water. And 3. Conduction, transfer of heat by actual physical contact, molecule to molecule. Any doubt till now? If yes, let me know in comment box. Then next is boiler specification. The heating surface is any part of the boiler metal that has hot gases of combustion on one side and water on the other. Any part of the boiler metal that actually contributes to making steam is heating surface. The amount of heating surface of a boiler is expressed in square meters. The larger the heating surface a boiler has, the more efficient it becomes. The quantity of the steam produced is indicated in tons of water evaporated to steam per hour. Maximum continuous rating is the hourly evaporation that can be maintained for 24 hours. Fn means the amount of steam generated from water at 100 degree to saturated steam at 100 degree calculus. Next is Indian Boiler Regulation. The Indian Boilers Act was enacted to consolidate and amend the law relating to steam boilers. Indian Boilers Regulation, IBR, was created in exercise of the powers conferred by Section 28 and 29 of the Indian Boilers Act. IBR steam boilers means any closed vessel exceeding 22.75 liters in capacity and which is used expressly for generating steam under pressure and includes any mounting or other fitting attached to such vessel, which is wholly or partly under pressure when the steam is shut off. Ibr Steam Pipe means any pipe through which steam passes from a boiler to a prime mover or other user or both, if pressure at which steam passes through such pipes exceeds 3.5 kilograms per centimeter square above atmospheric pressure or such pipe exceeds 254 mm in internal diameter and includes in either case any connected fitting of a steam pipe. Next topic is boiler systems. The boiler system comprises of feed water system, steam system and fuel system. The feed water system provides water to the boiler and regulates it automatically to meet the steam demand. Various valves provide access for maintenance and repair. The steam system collects and controls the steam produced in the boiler. Steam is directed through a piping system to the point of use. Throughout the system, steam pressure is regulated using valves and checked with steam pressure gauges. The fuel system includes all equipment used to provide fuel to generate the necessary heat. The equipment required in the fuel system depends on the type of fuel used in the system. The water supplied to the boiler that is converted into steam is called feed water. The two sources of feed water are, 1. Condensate or condensed steam returned from the processes and 2. Makeup water, treated raw water, which must come from outside the boiler room and plant processes. For higher boiler efficiencies, the feed water is preheated by Economizer, using the waste heat and the flue gas. Next topic is boiler types and classifications. There are virtually infinite numbers of boiler designs, but generally they fit into one of two categories. Let's discuss about fire tube boiler, which is also known as shell boilers. In fire tube boilers, water is circulated in shell side and combustion gas is within tubes. Fire tube or fire and tube boilers contain long steel tubes through which the hot gases from a furnace pass and around which the water to be converted to steam circulates. Refer figure. Fire tube boilers typically have a lower initial cost, are more fuel efficient and easier to operate, but they are limited generally to capacities of 25 tons per hour and pressures of 17.5 kilograms per centimeter square. Then here certain advantages and disadvantages of fire tube boilers is listed. Quickly go through it. Advantages are like, sudden large steam demand could be easily achieved. Then large water volume gives flexibility in changing steaming rate. The rate of change in water level is relatively slow. Then large water surface area in relation to steaming rate, which leads to number of advantages. Then disadvantages are: larger diameter limits the operating pressure to 27 bar and relatively lower steam rate. Then next type of boiler is water tube boiler. Here water circulates in tube and combustion gases in shell. Water tube or water and tube boilers in which the conditions are reversed, with the water passing through the tubes and the hot gases passing outside the tubes. These boilers can be of single or multiple drum type. These boilers can be built to any steam capacities and pressures, and have higher efficiencies than fire tube boilers. Then advantages and disadvantages of water tube boilers are discussed. PL. Go through it. Next type of boiler is package boiler. The packaged boiler is so called because it comes as a complete package. Once delivered to site, it requires only the steam, water pipe work, fuel supply and electrical connections to be made for it to become operational. Package boilers are generally of shell type with fire tube design so as to achieve high heat transfer rates by both radiation and convection. The features of package boilers are: small combustion space and high heat release rate resulting in faster evaporation. Large number of small diameter tubes leading to good convective heat transfer. Forced or induced draft systems resulting in good combustion efficiency. Number of passes resulting in better overall heat transfer. Higher thermal efficiency levels compared with other boilers. Next is Fbc boiler. When unevenly distributed air or gas is passed upward through a finely divided bed of solid particles such as sand supported on a fine mesh, the particles are undisturbed at low velocity. As air velocity is gradually increased, a stage is reached when the individual particles are suspended in the air stream. Further, increase in velocity gives rise to bubble formation, vigorous turbulence and rapid mixing, and the bed is said to be fluidized. If the sand in a fluidized state is heated to the ignition temperature of the coal and the coal is injected continuously into the bed, the coal will burn rapidly, and the bed attains a uniform temperature due to effective mixing. Proper air distribution is vital for maintaining uniform fluidization across the bed. Ash is disposed by dry and wet ash disposal systems. Fluidized bed combustion has significant advantages over conventional firing systems and offers multiple benefits, namely fuel flexibility, reduced emission of noxious pollutants such as SOx and NOx, compact boiler design and higher combustion efficiency. Advantages and disadvantages of fluid bed boiler are discussed. PL. Go through it by yourself. Next very important topic is performance evaluation of boilers. The performance parameters of boiler, like efficiency and evaporation ratio reduces with time due to poor combustion, heat transfer, surface fouling, and poor operation and maintenance. Even for a new boiler, reasons such as deteriorating fuel quality, water quality, etc. can result in poor boiler performance. Boiler efficiency tests help us to find out the deviation of boiler efficiency from the best efficiency and target problem area for corrective action. Boiler efficiency. Thermal efficiency of boiler is defined as the percentage of heat input that is effectively utilized to generate steam. There are two methods of assessing boiler efficiency. 1. The direct method, where the energy gain of the working fluid, water and steam, is compared with the energy content of the boiler fuel. 2. The indirect method, where the efficiency is the difference between the losses and the energy input. We'll make separate video and calculation of boiler performance with advantage and disadvantage of direct and indirect method. Next topic is boiler blowdown. When water is boiled and steam is generated, any dissolved solids contained in the water remain in the boiler. If more solids are put in with the feed water, they will concentrate and may eventually reach a level where their solubility in the water is exceeded and they deposit from the solution. Above a certain level of concentration, these solids encourage foaming and cause carryover of water into the steam. The deposits also lead to scale formation inside the boiler, resulting in localized overheating and finally causing boiler tube failure. It is, therefore, necessary to control the level of concentration of the solids, and this is achieved by the process of blowing down, where a certain volume of water is blown off and is automatically replaced by feed water, thus maintaining the optimum level of total dissolved solids, TDS, in the boiler water. Blowdown is necessary to protect the surfaces of the heat exchanger in the boiler. However, blowdown can be a significant source of heat loss, if improperly carried out. The maximum amount of total dissolved solids, TDS, concentration permissible in various types of boilers is given in table. Next is intermittent blowdown. The intermittent blowdown is given by manually operating a valve fitted to discharge pipe at lowest point of boiler shell to reduce parameters, TDS or conductivity, pH, silica and phosphates concentration, within prescribed limits so that steam quality is not likely to be affected. In intermittent blowdown, a large diameter line is open for a short period of time, the time being based on a thumb rule such as once in a shift for 2 minutes. Intermittent blowdown requires large short-term increases in the amount of feed water put into the boiler, and hence may necessitate larger feed water pumps than if continuous blowdown is used. Continuous blowdown. There is a steady and constant dispatch of small stream of concentrated boiler water, and replacement by steady and constant inflow of feed water. This ensures constant TDS and steam purity at given steam load. Once blowdown valve is set for a given conditions, there is no need for regular operator intervention. Even though large quantities of heat are wasted, opportunity exists for recovering this heat by blowing into a flash tank and generating flash steam. Finally, most important topic is energy conservation opportunities. The various energy efficiency opportunities in boiler system can be related to combustion, heat transfer, avoidable losses, high auxiliary power consumption, water quality and blowdown. Examining the following factors can indicate if a boiler is being run to maximize its efficiency. 1. Stack temperature. The stack temperature should be as low as possible. However, it should not be so low that water vapor in the exhaust condenses on the stack walls. This is important in fuels containing significant sulfur, as low temperature can lead to sulfur dew point corrosion. Stack temperatures greater than 200 degrees Celsius indicates potential for recovery of waste heat. It also indicates the scaling of heat transfer, recovery equipment, and hence the urgency of taking an early shutdown for water, flue side cleaning. 2. Feed water preheating using Economizer. Typically, the flue gases leaving a modern 3-pass shell boiler are at temperatures of 200 to 300 degrees. Thus, there is a potential to recover heat from these gases. The flue gas exit temperature from a boiler is usually maintained at a minimum of 200 degrees, so that the sulfur oxides in the flue gas do not condense and cause corrosion and heat transfer surfaces. When a clean fuel such as natural gas, LPG or gas oil is used, the economy of heat recovery must be worked out, as the flue gas temperature may be well below 200 degrees. The potential for energy saving depends on the type of boiler installed and the fuel used. For a typically older model shell boiler, with the flue gas exit temperature of 260 degrees, an economizer could be used to reduce it to 200 degrees, increasing the feed water temperature by 15 degrees. Increase in overall thermal efficiency would be in the order of 3%. For a modern 3-pass shell boiler firing natural gas with a flue gas exit temperature of 140 degrees, a condensing economizer would reduce the exit temperature to 65 degrees, increasing thermal efficiency by 5%. 3. Combustion air preheat. Combustion air preheating is an alternative to feed water heating. In order to improve thermal efficiency by 1%, the combustion air temperature must be raised by 20 degrees. Most gas and oil burners used in a boiler plant are not designed for high air preheat temperatures. Modern burners can withstand much higher combustion air preheat, so it is possible to consider such units as heat exchangers in the exit flue as an alternative to an economizer, when either space or high feed water return temperature make it viable. 4. Incomplete combustion. Incomplete combustion can arise from a shortage of air or surplus of fuel or poor distribution of fuel. It is usually obvious from the color or smoke, and must be corrected immediately. In the case of oil and gas-fired systems, CO or smoke, for oil-fired systems only, with normal or high excess air indicates burner system problems. A more frequent cause of incomplete combustion is the poor mixing of fuel and air at the burner. Poor oil fires can result from improper viscosity, worn tips, carbonization on tips and deterioration of diffusers or spinner plates. With coal firing, unburned carbon can comprise a big loss. It occurs as grit carry-over or carbon in ash and may amount to more than 2% of the heat supplied to the boiler. Non-uniform fuel size could be one of the reasons for incomplete combustion. In chain-grade stokers, large lumps will not burn out completely, while small pieces and fines may block the air passage, thus causing poor air distribution. In sprinkler stokers, stoker-grade condition, fuel distributors, windbox air regulation and overfire systems can affect carbon loss. Increase in the fines in pulverized coal also increases carbon loss. 5. Excess air control. Excess air is required in all practical cases to ensure complete combustion, to allow for the normal variations in combustion and to ensure satisfactory stack conditions for some fuels. The optimum excess air level for maximum boiler efficiency occurs when the sum of the losses due to incomplete combustion and loss due to heat and flue gases is minimum. This level varies with furnace design, type of burner, fuel and process variables. It can be determined by conducting tests with different air-fuel ratios. Controlling excess air to an optimum level always results in reduction in flue gas losses. For every 1% reduction in excess air there is approximately 0.6% rise in efficiency. 6. Blowdown heat recovery. Efficiency improvement, up to 2 percentage points. Blowdown of boilers to reduce the sludge and solid content allows heat to go down the drain. The amount of blowdown should be minimized by following a good water treatment program, but installing a heat exchanger and the blowdown line allows this waste heat to be used in preheating makeup and feed water. Heat recovery is most suitable for continuous blowdown operations, which in turn provides the best water treatment program. 7. Reduction of scaling and soot losses. In oil and coal-fired boilers, soot buildup on tubes acts as an insulator against heat transfer. Any such deposits should be removed on a regular basis. Elevated stack temperatures may indicate excessive soot buildup. Also, same result will occur due to scaling on the water side. High exit gas temperatures at normal excess air indicate poor heat transfer performance. This condition can result from a gradual buildup of gas side or water side deposits. Water side deposits require a review of water treatment procedures and tube cleaning to remove deposits. Stack temperatures should be checked and recorded regularly as an indicator of soot deposits. When this flue gas temperature rises about 20 AC above the temperature for a newly cleaned boiler, it is time to remove the soot deposits. 8. Variable speed control for fans, blowers and pumps. Variable speed control is an important means of achieving energy savings. Generally, combustion air control is affected by throttling dampers fitted at forced and induced draft fans. Though dampers are simple means of control, they lack accuracy, giving poor control characteristics at the top and bottom of the operating range. In general, if the load characteristic of the boiler is variable, the possibility of replacing the dampers by a VSD should be evaluated. 9. Effect of boiler loading on efficiency. The maximum efficiency of the boiler does not occur at full load, but at about 2/3 of the full load. If the load on the boiler decreases further, efficiency also tends to decrease. At zero output, the efficiency of the boiler is 0, and any fuel fired is used only to supply the losses. The factors affecting boiler efficiency are: as the load falls, so does the value of the mass flow rate of the flue gases through the tubes. This reduction in flow rate for the same heat transfer area reduce the exit flue gas temperatures by a small extent, reducing the sensible heat loss. Below half load, most combustion appliances need more excess air to burn the fuel completely. This increases the sensible heat loss. In general, efficiency of the boiler reduces significantly below 25% of the rated load, and as far as possible, operation of boilers below this level should be avoided. 10. Boiler replacement. The potential savings from replacing a boiler depend on the anticipated change in overall efficiency. A change in a boiler can be financially attractive if the existing boiler is old and inefficient, not capable of firing cheaper substitution fuel. Over or undersized for present requirements, not designed for ideal loading conditions. The feasibility study should examine all implications of long-term fuel availability and company growth plans. All financial and engineering factors should be considered. Since boiler plants traditionally have a useful life of well over 25 years, replacement must be carefully studied. Thank you. PL. Subscribe for further updates. I am preparing videos for the boiler efficiency calculation with case study of an industry. So, do subscribe for further updates and like the video and comment your doubts if any, will surely help you guys. Have a